Welcome back to the channel. In today's video I'm going to create an CD32 specific arcade stick as close color-wise to the original as possible. So let's get cracking. Today we are going to take a look at, no, not the CD32. I did that already in a video which I will, or may, if I don't forget, link there or somewhere. This machine, while not being an A1200 because it has the Akiko chip, and people told me that in the comments and I already knew that, but thank you, has a notoriously bad controller in the form of this, let's call it the dog bone. And it has a speciality, that is that it has a 9-pin DIN connector, but it has 1, 2, 3, 4, 5, 6, 7 buttons plus the D-pad, and that makes like 11 connections required plus a ground to actually make this work, and it only has 9. So how does it work? This controller has some LS logic inside that actually translate these buttons to something else, and pretty much makes a sequence out of this, a little bit like USB, not like USB but serialized information. And this controller is bad. Then there's this Honeybee controller, which is supposed to be the best CD32 controller, and there are also new controllers that just have this LS logic inside some kind, it looks like a SNES pad, Super Nintendo pad. What I want to do is I want to create a real arcade stick for the CD32. And I got all the parts. I got a PCB that should enable this, and I will show you in a minute. So I have a whole stack of stuff here which we need to actually create this, and I will start by showing you the actual stick. And I was looking on Amazon and eBay and all these places, AliExpress, and the cheapest case for an arcade stick I could come up with was, I think, 30 euros, $30, something like this. And I thought, that's pretty expensive. So maybe there's a way to actually use an existing arcade stick, because you also have to add the buttons and all that stuff, and that makes it about a 40-50 euro or dollar stick plus the logic you have to put into it. And I found these are wireless arcade sticks, and these are 2 actually, and I paid, I think, 36 euros for 2, shipped to my door. And these are compatible with Windows, Android and Mac. So you can't use these for the CD32, of course. These are even wireless. I didn't notice that when I ordered them. So the idea is, take one of these sticks, and you will see in a minute why I chose this stick, and mod it to be usable on the CD32, which means adding a cable and adding the logic, and removing the logic that's already in there. So let's take a peek inside this box. And there are actually 2 of these, plus some stuff. So we have our stick here, which screws in right here. I will leave it out for now. But what you can see is, if you put the original pad here, the colors match, which is nice. These are, well, these are not the greatest buttons, but you can always swap these out. So we have red, blue, green, yellow here. We have left and right, which is here. We have start and select, which is just 1 button here. And we have our D-pad in the form of a nice clicky joystick, which is great. So this is, we have some suction cups on the bottom, and we have an on-off switch here. So these actually take batteries. Interesting, we don't need that, so never mind. We can use this place where the switch is to route our cable through. And this is called the Y3 Arcade-Stick. And yeah, it takes 3 batteries. So this would go in here, and then this would go here, and then this would go right here. Ooh, this is nice. Then you have your stick. Yeah, that is very different from this here. So maybe we could even use this up here to be mapped on A. So if you want to jump, which is one of the main Amiga control schemes, that you have to go up to jump, you could put that on the A button. That would be interesting. I did that on my fighter joystick, I think, where the B button actually is jump or up. And we could make it switchable in this one. Okay, so what I haven't done is, I haven't opened this up. I don't know what that thing looks inside, if he has room for what I show you next, because, well, let me show you. So when I was thinking about building this stick here, I actually was looking for an arcade stick that was already pre-made to play on the CD32, and I found this stock bone controller for the Super Nintendo, which is modded, which cost about 50 euros. And I found this here. And on eBay, when I saw this, I thought this was just one of these super small PCBs, which is about, well, this is a post-it note, standard size. And if I put that here, you can see it's even bigger than a post-it note. And this is a PCB which takes 2 LS chips, 74LS165A and 74LS125A. And you connect your buttons here, you connect your cable here, a few resistors, a few caps, that's it. And you have a CD32 stick. And this is the AMI Arcade-32 version 1.1. I took very high-res photos. This is a 2-layer board, so you have just the back and the front. And you can easily reverse engineer this if you want to. It's just cables plus the logic here. But this is what I use. I have 2 of these, so I can actually build 2 sticks. And you need a few components, which I have already sorted out here. You need 10K resistors, one 2K2 resistor, 100 ohm resistor, 2 22 picofarad caps, 2 nanofarad cap, 100 nanofarad caps, and one 47 microfarad cap, and the SN74LS165A and the SN74LS125A, plus a few sockets and cables. For cables, if you go and cut off cables from standard joysticks, you might find that they mostly have 6 or 7 wires connected, which is too few. We need all the 9. So this is a serial cable, which usually has all 9 cables connected. So if I cut this off or cut this in half, I have 2. In this video we're going to build just 1. So these are the parts. Now let's take a peek inside this joystick and let's see if we can actually mod this and if there's space enough in there somewhere. And you can use these with these rubber feet or these suction cups or just the rubber feet. I'm very interested in seeing what's in here. And if I can open it. Yeah, great. There are screws under these rubber feet. Okay, let's try this again. Better. Wow, there's one cable connecting this. So we can cut this cable because we don't need that. And then we have this freed, which is nice. So this is the bottom. Here sits the stick on these things here. I put this here. Yeah, this just, I think this just pushes against this board up here. And that's the interesting part, because we have to get onto this board doesn't seem to be glued in somewhere. So let's just take this out. So we need this PCB, but if I take a look at this right here, I can see that it could be hard to fit. Would have to cut at least one of these standoffs, and this whole thing has to go, the battery compartment, which is not a big deal because if you put the cover on, you won't even see that it's missing. I think it's one piece. It's just a seam in the mold. Okay, and there's not much to see here. This will get interesting. Okay, so wow, look at this. This is really, really tiny. The whole logic is in here. So I thought there might be an extra board for that, but it isn't. Yeah, so this could be much more involved than I thought, because we have to get to the traces somewhere, and this is a single-sided board actually. So it's a super cheap made board, and it's just these rubber cones pushing against these contacts here. It's not even micro switched. And these buttons are pretty big. So what we will do is we take out all the colors, because we will have to rearrange them like on the gamepad. And we will disconnect the joystick, I think. But let me mark this. I don't know how it goes on here. Now we have the board. This is just a stick. Yeah. There's the other two buttons. But there's not much to do here on this thing. That will just stay where it is. And these are part of the mold too. You can remove these rings. So if you would like to enlarge these, you would have to remove the top here. Cut this free. So this might not be the ideal candidate for what I have planned, but let's see. I have ordered another set of buttons, which of course don't fit here because they would need the whole thing here. And if they would fit, yeah, they're about the same height. So we could very easily connect these without using this PCB here. So maybe the right way to go is to actually really drill this free and put the buttons in. Not sure yet. And these buttons are, well, these are micro switched. These are better than the others that were in here. And it would work. I would just have to cut all this right here. And then we would have a little bevel on which we could put this button. Not sure if that would go in there, to be honest, because this is not flat. I would have to cut these down too, just to make this work, and these snappers go in here, or glue them in. It would also be a way. But we could then bend these to the side, but I don't have these for these up here, so I would have to use this board anyway. Decisions. That would be the ideal solution to replace all the buttons, because then we wouldn't need this board, because we could connect the joystick straight from here. So it could be a bit involved to actually make this work. Or I could just scrap off the solder mask here and connect the wires that way. So if I would go in here on this spot where all the 8 lines are, I could make this work. So I think that would be my first attempt to actually try to scrap this off and connect wires here, and then connect these wires to the respective spots on here, which is up, down, left, right, and then the various joystick buttons. Yeah, so the minimum we can do is use this case and this stick with different buttons, which I could make fit in here. And the maximum is we use what we have minus the extra buttons and just use this here, which is probably the better way, because you just pay for this arcade stick and you're done. Okay, so let me try to get these here free and see how far I get. Yeah, the HDMI of my microscope is acting up, so I have to show you like this, which is actually the screen. And what I did is scratch all these things here, and these go to the buttons. There's A, X, B, Y, and left and right down here. So we need one ground. So how this works, these buttons just have these contacts which are divided, and if one of these rubber things here pushes down, there's a little contact inside, and that closes the contact between this, and then it grounds it basically. So we need a ground plane or a ground wire to connect these. And all these things here which have a line, let me show you. All these things that have a line have their own connection on the board, and these here, which are just free floating or seem to, are connected to ground. And there's ground. This one here is ground, so we have to connect. I can't see that. So this connects to this up here. No. So this is ground. So we have to connect all of these that have their own line, plus that one ground line up here. And then we have all we need to make this happen. And I will solder wires here. Some of these lines I didn't scratch because this is just the joysticks coming down here. And these two buttons down here, C and Z, actually don't go over here. So I have to cut or scrape these two lines here to get the contact to this. But that's not much of a deal. So then I have all the connections I need. So I have to use very thin wire to solder here. Yeah, and then solder these to that board here on this side here. And this is just one ground line here. So all the grounds could just be connected, or I think they actually are on the back side. Yeah, see, just have to connect one of these grounds and then you have your ground line. Yeah, that is pretty much it. And then we connect these here to the DB9 connector, put in some components, and off we go. Yeah, so let's solder some wires onto these teeny tiny contacts. So I just put some flux on here. I've already scraped these two buttons, and now there's some flux, and now I will just put some solder on here and then use some wire to connect. So there's my solder work. It's just a little silvery patch to which I then will have to connect my wires. Okay, and there are the other silvery patches. I have this super thin wire, and I will try to route these cables out here where the joystick was before, because I know there's room to do this. That's on too. And since we don't have to solder anymore here, we are just going to clean this a little and then put on some Kapton tape to just make sure that it doesn't come off. Okay, there are our two first wires soldered on. Let's check for continuity. So this is our Z or Z, and this should be our C. Yep. Okay, first two wires are on. Nice, very nice. Now for the others, and you might notice that I left some space between these, so I made a zigzag pattern so that I have some room to actually solder and I don't bridge while soldering. So I didn't expect that I had to do this, because I thought, well, it's all just normal buttons and you can just use them as they are. Turns out you can't. Got all the wires fixed. Let's put on some kept on tape and then let's see if they all have continuity. And I will later go and cut these traces so that we don't get some interference from here. Okay, let's see what we have. First one is A. Nice, works. Button problem solved, which is very good. That looks reasonably good. It won't come off, I hope. Yeah. Good, 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 good. So, we won't need this one here, so we have to still get the ground line from here. So I will remove this connector here. Okay. I can go and put another one of my wires here to be the ground. Okay. So that is all the prep we have. We could put this now back into the case, but you will have to cut traces here. I already put on kept on tape. Well, never mind. We'll so did remove the kept on tape here again, and we will do a cut right here across all these lines. And we will do a cut right here across all these lines. And that should completely isolate this whole logic here from the rest. And we just use these buttons here. So the cuts have been made, one here and one here. That should now isolate all this from the rest, and then put the kept on tape back on. So before we put in the board, we have to check how to put in the buttons. Okay, the two black buttons just go here and here. And then for reference, we have our controller here. And we have green up here and blue down here and red down here and yellow up here. This now matches the controller. And then we have these two smaller buttons here. And then we take the board and we put it, I think, on here, just like that. I will just route this to the side here, and the ground cable I will also route to the side here, so that it's a bit more organized. Okay, like this. So now we can screw this back in, and then we can test continuity with the buttons attached. Okay. Time to think about how to mount the main PCB, and I think the way to go here would be like this. Problem is there's all this stuff in the way. Yeah, I think if we do it like this, you only have to sacrifice this and the battery compartment, which is good. I think this is actually the way to go, and we have plenty of space to do stuff. Okay, let's get Dremlin. So there's my crude line where the PCB goes, and all that's in this line has to go. Okay, there it is. Nicely cut out. Now let's see if we can put the bottom back on. Let's put this back in here. Yeah, you cannot see that anything happened here, which is great. So let's try the PCB, which fits perfectly in here. Now, if I put this on here, that should also work. Yeah, closes perfectly. Nice. Okay. That brings us, now we have all the modding done on the case. that brings us to the final stage, which is populating the PCB and connecting the wires and then testing. So let me put this together and then we will see what goes. I have the fancy stand out to put the components in, and we start with a 10. We need 10K resistors which go in up here. And I will not bore you with all the stuff here. I will just fill them up and then we will see. You can put these in anywhere you like because it doesn't matter. There's no polarity for resistors. So make sure that you put the last 10K resistor here in R12 on the very right side, and there are two different ones, R10, R11, which we have separately. And these are 1/4 watt resistors. You can also use half watts, it doesn't matter. Because we are working with very low power here, it's just 5 volts max. Like that. And then I have two resistors here, 100R, which is 100 ohm, which goes on the right side here, R11. And make sure to measure these so that you don't put in the wrong resistors. Even though most Chinesium packages already have them labeled, don't trust them. Which is a good rule of thumb for everything electronics, because people make mistakes and that is really shitty. So I have 200 nanofarad, which have the designation 104 on them. These little ceramics. And these go next to the sockets, or where the sockets go in a minute. Here. And here, and again, there's no polarity. As you can see, the legs are both the same length. That is often an indicator. Then we have the C2, which is 47 microfarad, and the white stripe of the cap goes to the right side. So that's the negative. We will leave the legs a little longer for that, because we have to put this like this flat, so that we don't interfere with all the components or the buttons on the other side of the PCB. Then we have two 220 picofarad caps, which go into C4. And these have the designation 221 printed on them. Again, leave the legs a little longer so we can put them like this, and this like this, and this like this, to make it all nice and flat. And that is all the components, so there's only the sockets and the two LS chips left. So let me go and solder this in, which by just turning this around makes this very convenient and easy. And then we will take it from there. Okay, that's all the passives, as they are called, soldered in. So I will use sockets, so if one of these ever dies, I can simply replace it by removing it from the socket. You need a 16-pin and a 14-pin socket. I don't have a 14-pin socket, so I will just use a 4-pin and a 3-pin socket. Put these side by side, which works. Make sure that you put the notch on the right side. Okay, sockets are in. It's a bit crooked, but it will work, I hope. So let's put the ICs in. Okay, now it's in. It looks good. Also, notch to the right. And here we are. One final thing on the PCB before we connect the wires here and here. We have to make a wire bridge from here to here. So, okay, so now the PCB is complete. Nice. Now we have to connect some wires. Yay! So the switch we will leave out for now, but we will put on the ground wire first, which we can just connect anywhere, doesn't matter. I think we will put it up here, right next to U1. And then we have up, down, left, right. I will actually solder the wires directly to the joystick on the other side, so I will remove this here. Yeah, there we can just solder to the stick itself, which is much easier. You will leave these pins here. Okay, so all the 5 wires are connected here. Again, we use some kept on tape for strain relief. So we have to solder a second ground wire now for the stick, which is this one here. We can just use one of the other ground holes here. That's done. So now we have to find out which one of these wires is which direction. I will clip the yellow one to ground on the pins up here, which we have left intact, and the green one goes to the second probe and to the end of one of the wires. And let's see. Let me switch it on first. And it is up. Okay, good. We have our up, which is incidentally the first hole we have here. So let's try another one of these cables here. What I will do is I will take the PCB and put it on the back of this, and then solder the cables like this, so that they are not too long. We have this, we can align this one right here with the thing here, and that should be mounted here. That should be it, I think. Let's see. Yeah, it works. So we can actually see the PCB here, which is good, because then we can make some wackel. Like this. Now I know where to put it. Well, let's put this down there. Just like this. So now we have to connect the rest of the buttons, which are of course on the other side of the PCB. Why shouldn't they? So now the green goes to ground and the yellow goes to wherever I measure. So we have the yellow button. Okay, so all of the buttons are connected now. We still have the switch here, which I'm not sure what to do with. I did combine the select and start button, so either work as the start button on the PET. I just drilled them together and put them into the P position. Now I have to do some cable management again, which means routing these cables over here. So finally the switch. What do we do with the switch? Yeah, I think I will leave the switch out for now. Now the final act is to connect the DB9 cable. And for that I have to measure again which pin is which cable, and then we just measure it up and then we have a joystick, I think. The switch is just for show for now. Snippy. I really hope there are 9 cables in here. didn't check, to be honest. Let's see, 2, 4, 6, 8, 9. Whew, it's 9 cables. Whew. And one of these shield wires or grounds, which we don't need right now. Okay, so we have our 9 connections here. And again, we go in, we connect one side to a cable, and we make ourselves a little chart with the colors. And these colors are not coded, so if you have your own cable, you have to make your own chart. Yellow, blue, green, orange, and red. For the other side, we take one of these DuPont cables and put the yellow thing on the probe on the other side here, and now we just go and poke into the holes until we get a connection. And hope that we get a connection here. And there are actually numbers on here, and this is number 2. That's what you write down, number 2. And on with the next. So now we go and we just solder according to our little list here. I think we are done. So now we have to find a way to route the cable. And maybe this is workable like this. If I put the backside on and leave that switch cover off, that might actually work. Yes, it does. The cable is fitted nicely, doesn't move. So let's screw it back together and go and test it. Without any modification on the actual case, I think we made an Amiga CD32 stick. All that's left is to actually put in the stick. Very nice. I hope it works. Oh man. Okay, so I have my orange Amiga 500 here, and I don't know if you know, because I didn't, that you would actually use Amiga Test Kit on an A500 or any Amiga really to test a CD32 controller. So let's do this first before we plug it into the CD32, because this Amiga is made of trash parts, and if it dies I can repair it. And the CD32 is much more expensive to repair and to maintain than this one here. So let's switch it on. I have my Gotek connected, and it should directly go into Amiga Test Kit. So here we are in Amiga Test Kit, and we can go to controller ports, and then we can up here, because this is selectable, we can switch to CD32 PET. And if we now move the stick, that works. That's to be expected. We have A and B and X and Y, and we have the top buttons that work, and we have start and select. Amazing, it works. Wow. Didn't expect that to be, and to be totally honest, this is the first try. I haven't plugged this in anywhere. I'm just amazed. I mean, it looks good. I have not played it yet. Okay, so I think we're good to test on an actual CD32. Okay, so I have the CD32 connected. The joystick is in the relevant ports, and we are trying Oscar, one of the shitty games that I think shipped with one of the versions of the CD32, and we have to push R1, which is this one right here, twice to start it. Yeah, that works. So the cable color is to be discussed. White might not be the perfect color, but actually, well, it's black and white or gray and white, so whatever. Red, and that works too. That's loading, I think. Yeah, this actually works. "32-bit dance party." Okay. Okay, this game does not make use of any button, which might not be the best test case. Wow, this is one hell of a shitty game. I think that concludes this video. We have a cool arcade joystick which actually works with the CD32, and it's perfect. No modifications on the case. Switch is still here. Can use it if I want to. I'm happy. Looks like factory, and you can actually see the PCB. Nice. There's actually plenty of room, so you can socket all the chips if you like. It's not a problem. So this went almost too smooth, I think. I'm a bit shocked that it actually worked first try and without much preparation except for finding the right parts and stuff. And yeah, I will put all the links in the description below. So that concludes this video. Thanks for watching, and I see you in the next one. Bye bye.
Thank you for watching Retro is the New Black. If you are new to the channel, please like and subscribe. If you like the video, please share. Every like, share, and comment helps a lot. Until next time, bye-bye.